Hey folks, welcome to Quick Bites of AI, where we break down complex AI concepts into bite-sized, easy-to-digest pieces. Today, we're diving into something called an activation function. Now, I know that might sound like some hidden feature on your TV remote, but trust me, it's a super important part of neural networks and machine learning. So, let's start with the basics. Imagine a neural network as a series of layers, like a delicious onion. Each layer consists of nodes, which are kind of like our brain's neurons. The job of these nodes is to process input data and pass some output to the next layer. Now, here's where the magic sauce, the activation function, comes into play. The purpose of an activation function is to introduce nonlinearity into the output of a neuron. Let me put it this way. Without activation functions, our neural network would essentially become a really boring linear model and wouldn't be able to solve complex problems. An activation function gives the network the ability to learn sophisticated patterns, make sense of complex data, and perform those eureka moments, just like when you find out you've got a sock twin in the laundry. So why do we have different types of activation functions? Well, it's all about flexibility and performance. It's kind of like choosing a dance style. Salsa might be great for small spaces, but if you're in a large hall, a waltz could be more fitting. Let's talk about some popular activation functions, starting with the sigmoid function. Think of it as the ultimate squasher. It takes any input and squishes it into a range between 0 and 1. This makes it useful for models where you need a probability-like output. But, a funny thing about the sigmoid is that, like my introverted cat, it can be quite lazy with extremes. It tends to ignore really large positive or negative inputs. Next up, we have the ReLU, the rectified linear unit. ReLU is one of those straightforward, no-nonsense functions. Its mission is simple: pass positive inputs as they are, but for negative ones, it says, nope, and turns them to 0. ReLU has quickly become a favorite because it's computationally efficient and usually helps models converge or learn faster. But beware, it has a tendency to deactivate itself for too many negative inputs. Just like that one friend who refuses to budge from the couch. Then we've got 10H, which is kind of a sibling to the sigmoid, but on steroids. It outputs values between -1 and 1, giving it a bit more expressive oomph. This is helpful when you want output to be centered around 0. Your sentiment analysis, where emotions vary widely, might prefer 10H as it goes negative too. Not just negative. One question I often get is, why don't we just stick with linear functions? Well, using pure linear functions would be like trying to explain all movies ever made with a single storyline. Sounds boring, right? Nonlinear activation functions allow networks to learn and represent complex relationships within the data. So, which activation function is the best? Well, that's the golden question. It really depends on your particular project, the data, and what you're trying to achieve. It's like choosing the perfect pizza topping. It varies from person to person. And that's a wrap for today's episode on activation functions. Remember, these little guys are the unsung heroes giving our neural networks the power to solve complex problems. Thank you for joining Quick Bites of AI, and I hope you had as much fun listening as I had explaining. Don't forget to tune in next time where we'll dive into another juicy AI concept easy enough to chew over without a spoonful of coding. Stay curious and keep learning.